Hello, I'm Jack Lee, and this is Lab 11 Detectors.
This is for Opti 380A. RTA is Lab11, and this lab has two parts. Part A, which is using different detectors. Part B, which uses CMOS spectral and IR imaging.
Lab, we utilized the breadboard setup provided in lab in conjunction with the function generator, PD amplified a multimeter and the oscilloscope to create an optical measurement system. Furthermore, for our first part, we aligned the APD and PD detector to the yellow LED as shown in the setup on the right and began adjusting the oscilloscope amplitude to compare the responses of the APD and PD signals. For the second and third parts of this lab, we used a similar setup to record graphs of voltage versus power for a different PIN, photodiode, and photoconductor. Finally, using an emergency alarm, we measured the fall time from a PD detector from a pulse light source. Here are the graphs which are comparing the response of the avalanche photodiode to a basic diode. We can see on the picture on the left that at a higher amplitude the signals look eerily similar. However, the APD has much more noise. Moreover, at a lower amplitude in a PD SNR of 1, we notice that the APD has a very noisy signal. Here are the scatter plots for the relationship of open circuit voltage and current of the PIN photodiode versus the power output read by the photodiode amplifier. Here we can see that the voltage is logarithmically increasing with increase in power while the current is linearly increasing. Third section of part A, we used a photoconductor shown on the left to record the open circuit voltage versus the power read by the photodiode amplifier. On the graph on the right, we can see that similar to the PIN photodiode, the photoconductor responds logarithmically to light output. We can see that the voltage response of the PIN PD to a flashing light is different with and without the 47 ohm resistor. Moreover, without the 47 ohm resistor, the rise time of the voltage is 11 milliseconds. However, with the 47 ohm resistor, the rise of time decreases to 840 microseconds.
For the first part of Part B, we aligned an optical system containing a light source, a lens, a detector, and a resolution target. We then inserted a IR filter and obtained another image. We then replaced the white light source with a white LED and repeated these steps and observed the resolution at the end. We next did the second part of Part B using IR imaging. The results will be shown in the next slides. Here are the results for the first part of Part B with the CMOS detector. As you can see on the right side is the white light, the left is the LED. In lab, we verified visually that the white light source was much brighter, hence the difference in the image brightness for the LED and the white light. As you can see, the LED with the IR filter had a much greater difference in imaging than it did for the white light detector. Final part of Part B was the IR imaging. This was very challenging for us. It took by far the most amount of time just to be able to find the focus and the one-to-one magnification and such. But we were able to get fairly good images, as you can see on this slide.